I think the future of AI would actually be in biology.
They're most likely going to be used more towards predictions rather than just, getting stuff done like coding.
I think there's a possibility that in the next few years you'll see some sort of AI-driven calamity.
What do you think is worse, a nuclear weapon or a bioweapon? Okay, so you have been in NYU for around what 2 years now, 1.5 year, I think. What was the journey like getting into NYU from CBSE school?
Oh, so I mean, I didn't think of applying to NYU because the standard track, like for Indian parents, is that you go to IIT or you write NEET and go to AIMS or something like that. So he was actually like a student from my school who was my senior. He was like 1 year senior to me. Um, my parents saw him at some event, and then they got to know like he got into NYU with like a pretty good scholarship. So that's how they got to know about the university. Even I didn't know about it. I mean, I'm sure like a lot of people are not even aware of NYU being in Abu Dhabi.
Yeah.
But like, I think that's what got them interested in the aspect of it. It's not like it's a American university. It's because it has pretty good scholarship and it's big. It's a big university, so that's what they got them interested in it. So my application from then on was like more catered towards American university. And then, so that was my journey basically. Like it was like trying to beat the standard route that Indian parents take.
So you talked about getting into IIT, right?
Yeah.
So did you like write the exams? What are the exams that you got to write? Because I come from a commerce background. I don't know a lot about IIT and all of this.
Yeah, so pretty much I did write JE mains and advanced both. But when I wrote JE mains, like the first one in January, I wasn't sure about getting into NYU. So I wasn't really sure if I was gonna get accepted in the first place. So I did write JE mains with the full notion that I would get into IIT first and then maybe decide later. So the first exam in January, I tried my best, but then I mean after that I kind of like died preparation down a little. Um, yeah, so I wrote JE, I wrote the BitSat for BITS in India as well. And I wrote a bunch of other exams for Indian universities. Yeah.
So what are you doing right now in NYU? Because there are so many courses, in NYU. Even in the uni I'm studying in, there are like different schools, like business school and engineering schools.
Yeah.
What are you doing? What are you into right now?
So I'm studying physics and film studies at NYU. So the thing is, since it's liberal arts, you have like an option of doing almost anything you want, like a combination of everything. So I know someone who's studying biology and music. There's someone who's doing mathematics and graphic design, right? So liberal arts is a unique opportunity for like young students to get into anything that they want and like any interesting thing that they want. And it's not like Indian universities where some at least in India, in IIT for example, when you get placed into computer science or computer engineering, for example, you sort of are fixed to that title. You can't change.
Yeah.
So if you get civil engineering and say IIT Madras, you can't just switch to computer science. Right? But
That's
here you're given that opportunity. You can switch how much ever you want. And I recently switched in the last semester. I was doing bioengineering and I switched to biotechnology and bioengineering, but then I switched to physics at the end of the last semester. And you can switch as long as your requirements are met. And you're allowed to do that. Yeah. So I think that's useful.
So I'm guessing you have done a lot of research in different fields then, because how many times have you switched? So like,
Oh, yeah, good question. I went into, so I told my school, like CPSE school
yeah,
back in our own Markham, I told them I'm going to do electrical engineering, and they put that on the official like poster in our school and stuff. So a lot of parents who call to check in and like just to get information about applying to like NYU and other American universities, they think I'm doing electrical engineering. So I walked into university thinking I'll do electrical engineering. Then I switched to math, and then after the first semester, I switched to bioengineering. So I did bioengineering for 2 semesters. And then at the end of last semester, I switched to physics. So I've been around like 3 or 4 times, I think. So,
so because you have switched so many times, I'm guessing you have done a lot of research in different fields, right?
yeah.
Can we get into that?
Oh, yeah, sure. So I did a bit of, yeah, I started with research in biophysics and biomathematics. So that's how my introduction to biology actually began. So that's what got me interested in like bioengineering in the first place. So I switched from electrical engineering and math to bioengineering purely because of the research that was being done on campus. And then what got me into physics was that I somehow convinced my parents to like allow me to switch to physics because once again you have the stigma for Indian parents that you can't do pure sciences. So physics was always my interest, and I started with research in biophysics and then biomathematics, and now I'm doing machine learning as well, just to get a bit of taste around AI and um, large language models. So, just a brief overview of that. Would you like me to go into detail of it?
Yeah, I want to understand what kind of research, you know, you have gotten into. Yeah.
Okay. So starting off, like I did biophysics research where we basically studied um, the the structure of living cells. Okay, so there's a lot of things that differentiate um, life and death, right? So one of them are the physical responses that cells give you when you push them, like physically push them. So we were interested in studying a particular set of cells. They're known as C. elegans. So that's just a biological name. But we were interested in their response once you start like poking them with a stick. Like literally, we used to poke them with something called a pipette, and we were studying the physical and mechanical response of something called the cortex. So the cortex is just this thin layer beneath like each and every cell, beneath the membrane of each and every cell, and that's what gives it support to the cell. And initially, physicists are interested in studying the cortex in general because it's like when you look at the cortex from like a microscope, you see that it's actually resembling some unique crystal-like structures. So I can actually show you like the pictures after we're done, but it's really interesting because you see that they resemble something like a crystal, and like physicists are like they're entertained by stuff like this. So they started looking at at the cortex of C. elegans in particular, and that was my first research project to sort of like map out equations that would describe these these cortex and these organisms. And yeah, it was really fun because you sort of see the bridge between like biology and physics. So biology, you have to do a bit of both. So I started like with experiments. I started cutting up some worms, like the C. elegans worms, and then yeah, I was able to image them. So we use microscopy, like advanced microscopy, to image them, and then you get these beautiful images of like things that look like crystals, but they're actually inside our own bodies,
We'll
which is
put that up here, for the
yeah,
audience.
yeah, for sure. Like it's really amazing to see
That
that.
sounds really interesting.
Yeah, that was my first project, and then my second project was in biomathematics, where to sort of give you an idea of it, it's kind of like uh, there's this central like theory in biology that all biologists have to know, it's like a very fundamental theorem in biology. It's known as the central dogma, which basically means that you have DNA, right? And you like you're aware that DNA is like the building blocks of life. It's the genetic code for everything, right? So DNA basically uh, undergoes a process known as transcription, and it gets converted from DNA to something known as RNA. So they're kind of different in the chemical composition and how they look. So we can see that in images that I can share with you also. DNA is like a double helix. It's known as a double helix, but RNA is just like a single linear chain. It's just like a small chain. And then RNA also undergoes a process known as translation. So there's transcription from DNA to RNA, and then translation from RNA to proteins. So proteins are like so important in everyday life. Like every single thing, like can be broken down into proteins. Um, so yeah, that process we can actually describe it using different mathematical formula. Uh, in standard scenarios, when you look at DNA to RNA and like the lab experiment, so when you isolate DNA and you measure how much time it takes from getting converted to DNA to RNA, you see that it undergoes a particular frequency, and we can actually like gather data sets for this frequency, and we see that it follows some unique mathematical patterns we now call as probabilistic splicing. So that's a unique perspective that we got at NYUAD. So there was actually this professor who was interested in probabilistic splicing. So yeah, that was my second project. And about my third project, it's pretty much related to proteins and its stability. So I'm trying to team and I are actually working on sort of developing an AI model, that a large language model that sort of predicts the stability of proteins given the amino acid sequence. So yeah, that's
That
the
sounds
third.
insane.
Yeah, I mean the
Coming
third
from a
project.
tech background right now.
Yeah, I think it's. Oh, sorry. I think like AI has the most impactful uh, approach in biology. I think the future of AI would actually be in biology, nothing else. I don't think like chatbots or Gemini or ChatGPT are going to be the future, at least the
Well, I
near
feel
future.
like to an extent it would be the future for, chatbots and all of that. But I think it's going to go more in depth for biology, and yeah, that's where I feel like there's going to be a lot of research coming out.
I think like I think biology, particularly in like clinical applications, it's going to have a tremendous impact because it's like having had some research experience in this field, I can see that with the advent of AlphaFold, and which one like it's the first time in history for the Nobel Prize to award it to a computer scientist. So a computer scientist, two computer scientists actually won the Nobel Prize in chemistry in 2024. So that's remarkable. You see that even this year, at least last year in 2025, in physics, Jeffrey Hinton, he's the godfather of AI. He won the Nobel Prize in physics. So you see that even you see the AI like slowly seeping through
Different fields.
into different fields,
Yeah.
especially the pure sciences. So who knows? Maybe next year you'll see a computer scientist winning the Nobel Prize in physiology or medicine, right? So I think that there's a huge possibility for that. And given how much AI can predict, particularly the step like how proteins are useful, it has a huge impact in other fields also like ecology. So the same scientists who figured out the AlphaFold stuff in like 2024, the Google DeepMind, they also went on to like predict different proteins that could be useful for degrading like plastic. So that could minimize like plastic wastage and like the huge ecological concern plastic has on the environment. So yeah, I completely agree with you. Like in the coming years, maybe chatbots could be the use of chatbots would plateau, but I think
I feel like chatbots and AI models in general, they're most likely going to be used more towards predictions rather than just getting stuff done like coding.
I
And
see.
yeah, that's what I believe. Right now at the moment, coding is like really hiking up, but in the far future I feel like it's going to be used more towards prediction of economy, prediction of what could happen in the future with like different biological fields, different physical physics fields. Yeah,
I
that's
see.
what I believe.
So you think it has a possibility of uh, maybe in like the financial predicting financial.
Probably, I feel like it's gonna evolve into that.
What do you think of the ethics of that though? I think that's really a really concerning thing to.
Yeah, it is,
It's a really concerning thing to have because first and foremost, the financial market is broken.
and
I
it's getting worse
and it's
because of
yeah,
the wars.
and it's completely unnecessary that purely predicting, uh, you know, if a stock would go up or down would result in so much money. So if you, I mean, it's really concerning. I think because you can like predict a lot of puts as well. For example, even in before the war started on February 28th, there were a lot of put shares. So put shares is like the one where you predict the stock would go down. There were a lot of put shares that were going in for Dow Jones. The Dow Jones is basically the one that predicts the oil prices. So it's not just people who have insider information from the government that would know, okay, so since we're going to invade Iran, I can predict that the oil prices will go down. It's people who have used AI, like smart people who have used AI, that can kind of figure out, okay, why is there a military buildup in the Middle East? And uh, they can ask AI, is there a possibility that there's going to be like a military intervention during this period? And AI can give you like a rough estimate. I think that's how Claude was used um, by some people who predicted appropriately that, there's going to be invasion, and they put shares and they made a lot, like loads of money. And this is the first time AI is being used in financial markets. I think it's a really concerning thing.
Yeah,
Yeah. How do you think like could be tackled? I think.
I feel like it can't be tackled by the governments. The governments are going to use it, but also putting limitations to the general public. You know how at the moment there are a few things that can't be accessed by the general public. Even using ChatGPT, you can't. There are a certain amount of ethics and rules set up in ChatGPT that are not allowed for the general public. But obviously, the governments are gonna surpass those and gonna use it ethically, unethically.
Mm.
Everyone has a different opinion of that. But yeah, the governments would say that's really ethical, but for a big amount of population that's
Yeah.
being used against it, it is obviously going to be unethical.
Mhm.
But yeah, let's not go into that. You know,
Yeah. Yeah. I think the future of AI is uh, pretty concerning. Have you heard of Moore's law?
no.
So Moore's law was proposed by economist actually in I think early 1990s. So what Moore's law predicts is that the rate of technology it doubles each year. So it's not like a linear growth; it's exponential. It doubles each year. So the rate of economic output, according to Moore, is predicted by the amount of research papers that comes out in computer science, as well as the total energy output each year. And Moore's law is actually like a real thing. It is true, and they've seen it each year. Like you see that the amount of like energy and the amount of research that was put into AI last year is half of what is being done here, and next year is going to double. So we, I mean, like in the next month, we don't even know like the amount of research that's being done that's going to come out in the within the next month itself. So it could be something that's say could be used ethically, like you said, that governments have like no. purpose other than to impose it ethically. For example, like again, AlphaFold by Google DeepMind, it's purely ethical. It's for an ethical purpose, hopefully, because AlphaFold is something that's like it's an AI model that predicts the structure of proteins, right? So it's purely clinical. You can have like like I said, like you can have like ecological impacts with it, like positive ecological impacts with it, or you could, I don't know, maybe engineer a protein that can uh, engineer a protein that can sequester Ebola inside, for example, right? Which is like very alarming. It's just concerning. What if a bioterrorist organization comes up with with like some code, like a genetic code that can safely inhabit uh, Ebola inside it, and it which is cannot be defeated by current like uh, vaccines or antibiotics or something. I mean, for proteins, you usually use vaccines.
So what would that lead to?
I think that would lead to severe uh, like attacks across the world, uh, which have never been seen before, like the scale that is unforeseen.
Like virus kind of attacks?
Yes, I think
something like COVID.
Yeah, I mean, COVID, according to the World Health Organization, was not from a lab leak or like was not induced by any terrorist organizations or anything. Um, it was from like a wet market, but it could be to that scale or even worse. So COVID was particularly interesting because, according to like scientists that have studied it, it was passed down from a pangolin to a red panda and to a bat. So it passed through three organisms and was able to mutate in all three organisms. And then it passed on to humans. So it had that layers of protection. In layman terms, you can say that. It's like layers of protection that could survive three organisms. So, I mean, it was ravaging human lives. But I think if you engineer proteins itself, if you think of certain sequences that can be resistant to current and existing vaccines, that is the most concerning part. So
Could
say
be even more lethal.
I think it could be even more lethal.
Yeah, makes
And
sense.
if you have terrorist organizations that have the engineering like capability to think up some proteins that can like inhabit like dangerous substances, uh, given that you have these AI models like AlphaFold, so AlphaFold is a data bank with more than 200 million protein sequences and their structures. So a smart like bioterrorist could like devise another AI model that looks at these data sets and then comes up with something that's like resistant to all of the other uh, available vaccines, which is really concerning. So we need to have some. I think we need to have like some ethics committee, like particularly AI ethics committee in government, which I'm not sure if the US is gonna.
That would govern limitations.
Yeah, the use of AI. Precisely, that is what Google DeepMind did. So the person who won the Nobel Prize in physics, I mean, sorry, in chemistry in 2024 for AlphaFold, his name is Demis Haskvis, and he was the one who spearheaded the AI ethics committee in the UK government. So I feel like if the UK government is able to come up with something like this, I think it should be the next step for the US government to think of.
Even globally, not even
I
just
think
like
globally,
US and UK. There should be a global committee that would like look into all of these issues.
Yeah, it's AI is. I mean, it's
it could either like make a paradise on Earth or could completely destroy the whole humanity.
That's true.
That's the
Yeah,
the scary part about AI.
Yeah, this was the same discussion that was held in say the 1940s when they split the atom for the first time, right? In 1941, two scientists, Hahn and Schurber in Germany, they split the atom, the uranium atom in particular. So when Nazi scientists and when American scientists in particular discovered that there was this huge, like, powerful tool that's available to them in such a small quantity, like they, uh, to scale. Okay, think of Hiroshima and Nagasaki, for example, right? How much grams of uranium do you think actually fission underwent that process to explode? How many grams of uranium do you think actually underwent?
Like A really large amount,
How much do you think? Just give me a rough estimate. I'll tell you the answer.
like 5,000 kgs.
5,000 kilograms of uranium to fission, right, inside the bomb. So you have that bomb, right? The bomb that was dropped over Hiroshima, for
Yeah.
example. So you think there was 5,000 kilograms of uranium inside that bomb that fissioned to allow it to explode?
I have no idea.
Yeah, I'm just asking.
Yeah, I guess that's like
Because a lot of
wide
people,
guess.
even I used to think that there was a lot of uranium that was refined and used in this project.
Mhm.
It was 0.1 grams. 0.1 grams
for Hiroshima and
for
Nagasaki.
Hiroshima.
That's
0.1 gram
insane.
of actual uranium that actually fissioned inside the bomb that led to 55,000 people dying upon impact. 55,000 people died upon impact. The entire 2/3 of the city's buildings were completely evaporated. 2/3 of the city's buildings. Okay, Hiroshima was roughly the size of Dubai, right? Actually, half of it. Like it was, around half of the size of Dubai, but 2/3 of the city's buildings was completely gone, and many more people died because of radiation poisoning in the coming years. So 0.1 gram of uranium, right? But to avoid going on a tangent, that's the thing. People were really concerned about the power of uranium and power of radioactive materials and the power of fission, the power of nuclear activity or nuclear fission. That they devised the Atomic Energy Commission in the US, the AEC, and they were aware of the power of nuclear weapons as well. That's what the splitting the atom.
So what you're saying is the next huge weapon that's going to come up is going to be a bioweapon?
No, I think.
What do you think it's worse? What do you think is worse, a nuclear weapon or a bioweapon?
Because I think I think it would be more clear if I kind of finish the what I was trying to say. Because like AI.
We'll get into that question later.
Yeah, because AI, I was trying to imply that. So in the 1940s, you had the discovery of splitting the atom. That it is possible to split the atom, and it is possible to undergo nuclear fission. So there is this process. It's called nuclear fission. Okay. So humanity from then on, in 1941, after the discovery of fission, they said they could go in two paths. The Manhattan Project was one path. Oppenheimer looked at the possibility of splitting the uranium atom and said, okay, there are other radioactive materials. Why can't we split them? Like plutonium, right? And the Manhattan Project was one avenue, right? And that led to the discovery of nuclear weapons, which is a one of the worst weapons that are. I mean, I think it is the worst weapon that is ever devised by mankind.
Yeah.
Right. That was one direction, and the other direction, I think, there were some scientists who were thinking about harnessing the ability of nuclear fission for energy and electricity, and that's why you have nuclear power plants here. Even in the UAE, you have the Baraka nuclear plants. So nuclear energy is also the most sustainable. It does not generate any greenhouse gas that can harm the atmosphere, and it is the most effective. It generates the most power that you can see in the households. So actually, the most common statistic people pass around is that in the U.S., nuclear powers, nuclear energy powers 60% of homes in the U.S. 60%, ever since 1941. So that's remarkable because you see that you have this scientific discovery, and you can branch it off to two different directions: one that harms humanity, and one that actually benefits humanity.
Yeah.
So that's the same thing with AI we're seeing here. People are panicking. People panic after you could discover that you could split the atom, the uranium atom. So people are panicking. We're in that stage where we are panicking, and we're in that stage where we can see there are two possible directions. One that benefits humanity, and one that actually leads to humanity. There's a chance that humanity inches closer to actual destruction. So I think there is a possibility of some sort of AI-driven bioterrorism in the next few years, or AI-driven malware attacks in the next few years, to actually push humans to think that. I mean, look at it. Look at this. After the atomic bomb was dropped and the war ended, was when the UN was formed.
Yeah.
So I think humanity needs to get that push first to actually sort of figure out, okay, we might need to
The
stop
defenses.
this. Yeah.
Oh my God.
So I think there's a possibility that in the next few years you'll see some sort of AI-driven calamity that would push the world governments to come together to form a committee. So, yeah, I completely agree with you in the case that we need a global ethics committee, and especially in AI ethics.
Yeah.
And coming to your question about bioterrorism or nuclear weapons, I think bioterrorism is one
Is
of the
worse.
worst. It is. It is. I don't think people can easily wrap their heads around how powerful a bioweapon can be. Nuclear weapons, sure, they're powerful, but the thing is, nuclear weapons don't spread, and they don't have. Sure, they have a mushroom cloud, but they don't have a radioactive cloud. Once you detonate a nuclear weapon, it's done, right? You wipe out a city. It's really
But
unfortunate.
there is radiation that spreads too, right, from nuclear weapons.
That's actually a misconception. Nuclear weapons do not actually spread any radioactive cloud.
Really?
It's purely the energy from. It's because the heat that's generated from the nuclear explosion actually like evaporates the very atoms that would cause the radiation, if that makes sense.
Mm-hmm.
So, for example, that's what I brought the uranium concern up, the uranium question. 0.1 grams of uranium. Why is it 0.1 grams? The scientists actually put together a lot more. I think it was in the order of kilograms, like hundreds of kilograms.
Yeah.
But they all
With
evaporated.
TNT,
Huh?
if you compare it with TNT, how much is that?
Uh, would-
If you compare the uranium atom and the weight of uranium, and if you compare the explosion
okay.
with TNT, how much would it be?
So, the one that was dropped over Hiroshima, if I'm not mistaken, was 50,000 tons of TNT. And it was all fit into like one small. It was called like, I think it was called Little Boy. The bomb was called Little Boy. And it was devastating. So you see that your concern might be valid that there might be radioactive elements that might be present, but that actually gets sucked up in the clouds, right? But from the impact itself, there's little to no chance that radiation itself would spread, if that makes sense, right? Ionizing radiation that actually can damage your bones, but it doesn't spread. So after the impact, immediately after the impact, there's a possibility that you will get hit with ionizing radiation, but it doesn't linger, if that makes sense. Like
As compared to bioweapons.
So,
but don't you think using a bioweapon is self-destructive too?
that really depends. So, if you have like an international organization, right? If you have an international terrorist organization, or even if you're an army, you would advise against bioterrorism or bioweapons, because there's a chance, like you said, that it affects your own people, your own army, or there's a possibility that it might come back to you. So uh, in that case, it would not be advised. But what if you were like a lone, rogue agent from an organization, right? There are a lot of organizations in the U.S. that actually focus specifically on bioweapons. One is the U.S. Army Reserve for Institute for Infectious Diseases, so IID. It's called USAMRID. It's the U.S. Army Institute for Infectious Diseases, and they focus specifically on the Army's use for bioweapons. And what if, think about it, like what if there's a scientist inside USAMRID? Okay, he's just a citizen, but what if he goes rogue? What if, uh, you know, what if he just has an idea of, or like he develops a mindset or like psychotic mindset that he wants to hurt other people? There's a possibility.
Yeah.
And to prevent this, I mean, the institute like undergoes a lot of vetting processes for these scientists, but still there's a possibility that this scientist can go rogue and wants to harm other people, and he releases this bioweapon into the public. And this has happened before, actually. In 2001, right after the 9/11 attacks in September, in late September, there was a scientist. It's not confirmed yet, but there was this bioweapon known as anthrax. Actually, have you heard of it? Anthrax. It's a very deadly bioweapon that actually occurs naturally. Uh, It's called Bacillus anthracis, which is like a small spore. So they occur in like textiles, like uh, silk and stuff, but they're usually like in such small concentration that they usually just die off. But once they're in an environment which they don't like, the organisms when they're in an environment they don't like, they start to reproduce like mad. So like if you start with like 100 spores, within like 2 days they grow up to 1 million, right? And the thing is, uh, if humans inhale them, uh, they undergo something known as anthrax poisoning, which is like extremely deadly. So this happened in 2001, where there was a scientist. This is suspected, by the way. The FBI thinks this is the main suspect, where there was a scientist from USAMRIID, the same space in the same institute I'm talking about, who specialized in anthrax studies, and he went insane. He went clinically insane, and he mailed off several letters through the U.S. Postal Service to the the Congress, to some senators and House of Representatives in the Capitol Hill. He sent it to some newspaper outlets like the New York Times, the Washington Post. So all these major organizations that are like the backbone of the U.S. economy, he sent out these letters. It seemed like unassuming letters uh, to all of these people, and upon opening these letters, they were infected with deadly levels of anthrax, and approximately 5 people died, and they had to do like severe containment. He sent out around 10 letters, 11 letters, and more than 200 people were like severely uh, injured in the sense that they underwent like they had to undergo brain surgery, or they were left with permanent brain damage, and 5 people died. So
Would there be any kind of precautions that a person would want to take if there was any kind of bioweapon release?
I don't think there is. I don't think that it's that is the that is the
That what makes it even more deadlier than nuclear
I think
bombs?
so. I think so.
Makes sense.
My opinion is that bioweapons are much more deadly than nuclear weapons because they have the possibility of spreading and the possibility that you can never contain it once it leaves, right?
Yeah.
For example, if say a country drops a nuclear bomb at their enemy's country, right? Immediately there will be international backlash, right? Sanctions, uh, economic downfall, immediate, almost effective immediately, right? And then you drop one nuclear bomb. As macabre as it sounds, people die. That's true. People will die. A large number of people will die. But after that, there would not be a spread or like constant bombing after that, right? Hopefully, like this
Yeah.
is the this is the
There could be a high chance that there won't be.
there is a very high chance that there won't be a secondary attack.
Yeah.
Maybe a retaliatory attack.
Or even if there is, it would just be between the two countries or
That's
the
true.
amount of countries that have been
That is
fighting.
true.
Yeah.
That is true. And there would be a rampant fear. That is, I agree with that. But there is a possibility of dialogue, right? There is a possibility that these countries could talk to each other and reach a conclusion. But the thing is, with a bioweapon, I don't think you can really contain it until you find a vaccine. I don't think there's ever like.
But if a person is releasing a bioweapon, for example, let's say I am the one who releases a
Okay.
bioweapon,
Okay.
I would not
God forbid.
release it. I would not release it unless I have a vaccine to it, right? Wouldn't that be the case?
That's a logical way to think about it. That would be the approach some maybe some armies would take, maybe like the US or China. They would obviously have a vaccine to it.
Yeah.
But it comes back to that point where what if it's a person,
If it's a single person,
if it's a
it
single
would-
person
yeah.
who just has nothing to lose, who just wants to fortunately see the world burn, right? And I mean, as humans have seen, like I mean, throughout mankind's history, we have seen instances uh, occurring periodically, which is really scary. I mean, in the 1900s, you had 2 world wars, and you had multiple genocides. Even the first 40 years, more than hundreds of ethnic cleansing events. I mean, we had the Holocaust, was really that was really the talking point for a lot of Western countries. But you also had the Armenian genocide. You had the uh, you had the Peruvian genocide in the early 1900s. These are all incidents that people don't talk about. Um, and the thing is, it all started, I think, with a person and their ideology. So, uh, I think if it's a group of people or one person or a group of people who have nothing to lose, it is it can lead to catastrophic events. For example, jumping back to anthrax, actually, this 2001 event, uh, the person who released this, the scientist, is an American scientist. Uh, he actually wrote on the letters like "Death to America, death to Israel," and he started to show like he started try to impersonate that it was actually a Muslim group that behind the attack, like a jihadist Muslim group behind the attack, just to perpetrate that whoever did 9/11 was possibly behind the anthrax attacks. Um, so that's the thing with the shift in ideologies between people is what is most concerning. Like if you have that much hatred for for another culture or subgroup of people, then it can lead to people doing crazy things like this. You know, it is just the pure hatred he had that he wanted to impersonate someone else, some other group, some jihadist group, just to carry out this like heinous attacks. And the only reason the anthrax didn't spread was because of the insane levels of control. They closed down Capitol Hill for a month to clean off the anthrax, right? And luckily, since the anthrax was spread through the U.S. Postal Service (USPS) through the envelopes, they were able to contain it just by closing off some like posts. Yeah, some like post offices. So luckily, it didn't spread in the immediate vicinity of people. Imagine it was someone who had anthrax powder, and he just like I don't know, maybe held a fan outside and just uh, let it spread. That would be catastrophic.
Yeah.
Because anthrax is it's a very fine powder that can travel in the air, and if you release some spores, it can multiply. Like I said, can multiply into billions within like a week. So it's really catastrophic. Um, so I have another example on this. It's called. It happened in Japan, in Osaka and Tokyo. It's called. It was by a cult actually. It's called Shinrikyo, AUM Shinrikyo. They were a occultist group that was centered around one man who believed that he was God. And in the early 1990s, I think around 1994, they released anthrax around the subway in Tokyo. And I think a small number of people died, but they unleashed havoc in Tokyo because they planned to release anthrax over the entire city of Tokyo through their helicopters. So they had helicopters, and if that happened, if that plan went through, you would see a graveyard where Tokyo is today. It's
Makes
it's just the severity of bioweapons.
With all the amount of knowledge you have on bioweapons, do you plan on doing research into bioweapons?
Maybe it's like
That's a really interesting topic to think about.
I think because considering policy, particularly public policy, in such a disastrous time in humanity, I think it's something that is worth looking into, especially as a growing biologist and a physicist. And it is important to make yourself known that sometimes the things you work with, right, may be used against you.
Yeah.
Right? So yeah, maybe like going forward, I would love to have like some discussions about bioweapons with some people, and maybe not. I'm not that aware of public policy and like drafting white papers and stuff, but I would love to have discussions with people, and like especially in bioweapons and its safety.
So, what's your plan after getting graduated from NYU? Like, what do you want to do? Masters and PhD? Is that?
Yeah, I think my future plan right now is to do a PhD, probably in molecular biology or molecular biophysics, and I'm leaning towards more of like cancer studies or cancer genomics approach. Uh, yeah, I think that's also very interesting because within the next 40 years, with the rate that cancer studies are growing, we might see a cure for like a the most common type of cancers within the next 40 years, and I think that's exciting.
That sounds amazing.
Yeah, to able to actually be involved in such a growing field and such a elegant field, I think. So possibly my PhD is going to be. I'm not thinking of masters, but like a direct jump to PhD studies. So that's just. I mean, I'm in my second year, so I'm still thinking of some
Yeah.
possible opportunities. But let's see where it goes. Yeah.